My name is Shamira from the ESA Education Office. The world's oceans consist of two types of currents, surface currents and deep water currents. But how does the water sink to form deep ocean water currents? Let's investigate more.
Covering 71% of the planet, oceans are intrinsically linked to our weather and climate. They are also essential for global transport and provide a wealth of resources. What happens far out to sea has a direct impact on societies all over the world. Ocean currents are driven by surface winds, differences in water density due to salinity and temperature variation, and by Earth's rotation. Ocean circulation and the ocean's capacity to accumulate and slowly release the energy it receives from the sun play a crucial role in moderating the climate. For this activity, you will need optional gloves, 2 beakers, colored ice cubes, a teaspoon, salt, water. Fill 2 beakers with roughly 200 milliliters of tap water. Mix 2 teaspoons of salt into one of the beakers and let it settle until the water is clear. Gently drop 2 ice cubes into each of the beakers. As the ice starts melting, observe and record the behavior of the fluids. Beaker 1 contains salt water, which has a higher density than the fresh melting water. Therefore, the colored water from the melting ice cubes accumulates as a layer on top of the water in Beaker 1. In Beaker 2, the melting water is colder than the water in the beaker, and the colored water is sinking. This creates some turbulence in mixing, resulting in coloring of all the water in the beaker. Cold, dense polar water sinks and moves along the ocean bottom toward the equator, while warm water travels from the equator towards the poles.